Now in this video we're going to be looking at polynomials, and in polynomials we're going to look at how it relates to a function, which of course it is one, a function, and secondly it is in the form that is expressed as the following, where p at x is a function where p at x is equal to a subscript n multiplied by x to the power of n, plus we have a subscript n minus 1 multiplied by x to the power of n minus 1, plus this continues until it approaches plus a subscript 1 multiplied by x to the power of 1, plus finally our x is to the power of 0, which in this case is 1 multiplied by the specific subscript, which is 0. So the initial value, or the constant, which is what we have at a naught. But anyways, we'll talk more about that. Now take note that in this case n is an integer, and where n is an integer, it is not only an integer but a positive one, and this is indication of how it is expressed as a polynomial. And you notice as you move from left to right that it decreases by 1, and so by observing that we can see based on the subscript that if we have a subscript n to not be equal to 0, which in this case the a subscript implies that it is a coefficient, therefore this indicates that the polynomial is highlighted to be having a degree that is equal to n. Therefore, if in this case the a to the subscript n, in this case n is 3, as a result of that x to the power of n will be 3. That means the subscript that is going to be moving from left to right will be less than 3. In this case this will be 2, and this will be 2, this will be 1, as this is 1, and this is 4, 0, where x to the power of n, in this case n, is going to be equal to 0. So that is something to keep in mind when it comes to polynomials. Now recall a specific type of theorem which we call to be called a factor theorem, and a factor theorem is expressed as the following: if p is a polynomial, therefore we need to recognize that c is considered to be a real number. And to highlight what it means for c to be a real number, we are considering c to be part of x, and so consider c to be a part of x, which is specific x. Then we can say that where p at c is equal to 0, as we see in terms of a polynomial at a specific point, therefore this means that take note that y is equal to 0. So that means our c is considered to be the specific point where our curve is touching the x-axis. So if we have a graph right here, and we have this to be our y, which is also expressed at p at x, and this here is our x. If we have a polynomial curve that is shown in this particular pattern or manner, this in this case implies that, hey, we have a negative n behavior the right side, which means that this here has 3 points of intersection, which means that the intersection on the x-axis is considered to be where P at C is equal to 0, or P at X is equal to 0. So in here we have P at X to be equal to 0. In here we have P at X to be equal to 0. And in here we have our P at X to be equal to 0. So we are stating that if P at C is equal to 0, in this case C is taking the place of X, therefore we can conclude that X minus C is a factor of P at X. And so that is the conclusion that is made based on this particular assumption. If, for example, your C is at the other side of the X, we will say that X plus C is a factor of P at X. So these are the things to keep in mind when it comes to polynomials. This, by the way, this curve is an expression for our degree of x to be 3. Therefore, in this case, when we kind of break this down, we have something that is to the power of 3 as the highest degree for this function, and anything that comes after that will be less than, in this case, 3 as the exponent, and that is something to keep in mind. So that is about it for introductory video to polynomials, and I hope you found this introductory video informative. On our next video, we're going to look at we'll look more into polynomials, and also we'll look at analytical geometry. That is coming up next. All the same, thanks for following me through this. Truly appreciate it. See you on the next one. Stay smart as always, and believe in yourselves.